So let's go on with the next one then. What mass of MnO2 will be left at the end of the experiment? All right. Now this is now a stoichiometry question. All right. So what mass of the MnO2 will be present at the end? It's a catalyst. All right. So what do we know about a catalyst? The catalyst is part of the reaction, but it never gets used up in the reaction. Okay. So the question is, what mass of MnO2 will be left? So it's not part of the reaction. So the answer will then be, guys, 1 grams. So we started with 1 grams. We end with 1 grams. Why? It is a catalyst. It does not undergo any permanent changes. It is not part of the reaction. It just speeds up the reaction. Okay. Then 5.4, we go to the definition. This definition is very, very important. It's like one of those definitions, guys, where I always tell you this definition you will always get. Okay, so this definition which we have here is the rate of the reaction definition, and it's always the same. Please make sure you know this definition. It's always, always, always the same. The rate of the reaction is the change in the concentration of the products per unit time. So make sure you know this reaction. This is the one from the exam guideline. Okay. Then we get to 5.5. We use the collision theory and explain how a catalyst increases the rate of the reaction. Okay, guys. So if we use the collision theory, okay, I'm coming to come back to you guys. Okay, if we use the collision theory, what is the 3 things that we must have in our answer? What is the 3 things we need to look at? Do you know? Moshe, Mamitsela, do you guys know what we need to look at for? Or is it too early? Hello? Moshe, Mamitsela, do you have an answer for me?
No, sir.
No. So the 3 things we look for is then, number 1, we must make sure about the collisions. Okay? The collisions is the first one. So are they more effective collisions per unit time, or are they less effective collisions per unit time? That means if it's more, we have a higher reaction rate. If it's less, we have a lower reaction rate. Then if we go to the second one, is the particles in the correct orientation. Okay, so remember, if there's more particles of the correct orientation, obviously we will have a higher reaction rate. The third thing we look at is there sufficient kinetic energy? Okay, so there's 2 things that give sufficient kinetic energy, and that is concentration if it increases, if we have a higher temperature, number 3, if we have a catalyst, okay, and if we change the surface area. All right, so that's actually our factors we use in the rate of the reaction. So they can all increase the kinetic energy. All right, so let's continue now. Let's go to the answer now of this question. Okay, so use the collision theory and explain how a catalyst increases the reaction rate. All right, so let's go. All right, so number 1, we will know that the minimum, because we're using a catalyst, activation energy is lowered by the catalyst. Okay, but now this has nothing to do with our collision theory. Sorry. This has nothing to do with our collision theory. But because this is what the catalyst does, what happens? If we lower the activation energy, number one, we will have sufficient kinetic energy okay, then we will then have more effective collisions per unit time. Okay. The third one, which we have this morning, then is, remember we did talk about there will be more particles or compounds or atoms with the correct orientation. Okay, so there is question 5.5. Any question from your side, Mabitsela and Moshe?
No, sir.
No.
Mabitsela, any question?
No,
Okay,
sir.
so can we go to a second question?